Just as we saw where you can add and subtract complex numbers just as if they're regular polynomial expressions, same thing is true when it comes to multiplying. We're going to use the distributive property on this first one. We're going to use FOIL on this second one. The catch is, after we're done with that FOIL, unlike a regular polynomial where if you have an x squared, you just have an x squared in your answer, any I squareds need to be converted into negative ones. Because if you'll recall, I was defined as being the square root of negative 1. So if I square both sides, that means I squared equals negative 1. So I'm going to need to make that swap anytime an expression has an I squared in it. So back to this first example, if I distribute that 3i, we've got 3i times 9 is 27i. And we've got 3i times negative 3i, so that's going to become negative 9i squared. So now I'm going to replace that I squared with a negative 1 based on what we've got here. So I've got 27i minus 9 times negative 1. So negative 9 times negative 1, I'm going to get 27i plus 9, or if I just move over here, we want to write it in that a plus bi format. We want to put the real part first, followed by the imaginary. So we're going to have 9 plus 27i is going to be our result. In our second example here, we're going to use FOIL to multiply these out. So I'm going to multiply 6 times 4 to get us started, so we get 24. My outer term is this 6 times 2i, so I get a positive 12i. My inner term is this negative 2i times 4, so negative 8i. And then finally I've got negative 2i times positive 2i, so I get negative 4i squared. So now I've got a few things to do here. Number one, I've got some like terms in the middle that I'm going to combine. But then I also have this I squared again that I need to change into a negative 1. So I've got 24, we'll keep that there. 12i minus 8i gives us 4i. And then I've got negative 4 times I squared gets swapped out for a negative 1. So we've got negative 4 times negative 1. So if we keep going here, we've got 24 plus 4i, and then negative 4 times, that's a negative 1 in there, so we're going to get positive 4. And so now I've got one more round of like terms to gather. I've got 24 plus 4 makes 28, and then plus 4i. For the bottom two examples, it's very important that we recognize that exponents don't distribute. So I'm not just going to square the individual pieces and keep them connected by a subtraction symbol or something like that. I'm not going to do that. I have to use the FOIL technique to multiply out something like this. So I need to rewrite this as 1 minus I times 1 minus I. And so now I'm going to use the same technique that I did in the previous question, where I'm going to multiply my firsts. I get 1 times 1 is 1. I've got my outer and inner terms. Now in this case, those are both going to be the same. So I'm going to get a minus I, and then I'm going to get another minus I. So I'm just going to immediately combine those into a minus 2i. And then I've got my last. Negative I times negative I is going to give me positive I squared. So I've got 1 minus 2i. Oops, let's try to take care of that. And then my I squared is going to get replaced with negative 1. So instead of plus I squared, I swap that out for a negative 1. And so now I gather my like terms. Well, the 1 and the negative 1 here cancel each other out. Those are gone. And so we're left with just negative 2i as our answer. Jumping to the last one, same idea. I can't just square the individual pieces. When you're squaring a binomial, you have to use our FOIL technique. So I've got 6 plus 4i times another 6 plus 4i. So my first 6 times 6 is 36. My outer and inner, again, these are two of the same thing. I'm going to get a 24i plus another 24i, so that's going to make 48i. And then lastly, I've got 4i times 4i It's going to give me a positive 16i squared. So 36 can stay put, 48i can stay put. I just need to convert this I squared into negative 1. So really what we're looking at is 36 plus negative 16, or 36 minus 16. So that's going to give us 20. And then we still have our plus 48i. So when we're multiplying complex numbers, we treat them just like it was a regular variable that was included in the expressions. It's just whenever we see that I squared anywhere, we have to convert it to a negative 1 and then do any gathering of like terms that offers us from there.